students, today we will discuss about some properties of limits. So let us write them one by one. Property number 1, limit of a constant c as x tends to a will be equal to c. Let us see an example. Limit of 7 as x tends to 3 will be equal to 7. Property number 2. Limit of fx plus gx as x tends to a is equal to limit of fx as x tends to a plus limit of gx as x tends to a. Same property holds if in place of plus we have minus, and same property holds if in place of plus we have multiplication. So let us write in short property number 3, limit of f minus g as x tends to a will be equal to limit of f as x tends to a minus limit of g as x tends to a. Similarly, we will write property number 4 for multiplication. Limit of f multiplied with g as x tends to a will be equal to limit of f as x tends to a multiplied with limit of g as x tends to a. Same way we can write property number 5. Property number 5 is related to division. Let us write it. Limit of f divided by g as x tends to a is equal to limit of f as x tends to a divided by limit of g as x tends to a. But here in property number 5, because we are dealing with division, so we have to be very careful. We know that division by 0 is not defined, and hence in property number 5 we will put one condition, that will be that our denominator should not be equal to 0. So the condition we will write as limit of g as x tends to a should not be equal to 0. Let us write property number 6. Limit of a constant c multiplied by a function fx as x tends to a. This will be equal to, using property number 4, we will have limit of c as x tends to a multiplied by limit of fx as x tends to a. And now, using property number 1, we know that limit of a constant is the constant itself. Therefore, limit of c as x tends to a will be c, using property number 1, multiplied by limit of fx as x tends to a. So in short, we can write it as that limit x tending to a of a constant c multiplied by a function f. So what happens? This c, the constant c, will jump outside the limit. So this will give us c outside multiplied by limit of the function f as x tending to a. Let us write property number 7. Suppose n is a positive integer. In this case, limit of f to the power n as x tends to a will be equal to limit of f as x tends to a whole power n. Same way we can write for nth root also. We can write limit x tending to a of nth root of the function f. This will be equal to limit of the function f as x tending to a, and then we will take the nth root. And now we come to two important theorems. Theorem number 1. If Px is a polynomial, then limit of the polynomial Px as x tending to a will be equal to PA. Let us try to understand this using a simple example. Let us take limit of a quadratic polynomial, that is a polynomial of degree 2. Let us take a simple polynomial, let's say x square plus 3x plus 1 as x tending to 4. So what we will do, using theorem number 1, we will simply replace x by a. Here our a is 4. So in the polynomial we will simply put x equal to 4 and we will get the limit. Therefore we get 4 square plus 3 multiplied with 4 plus 1. This will give us 16 plus 12 plus 1, and this gives us 29. Now let us write theorem number 2. Theorem number 2 deals with rational functions. Rational functions are the functions which are in the form px divided by qx, where px and qx are both polynomials. So whenever one polynomial divides another polynomial, such type of functions are called as rational functions. So we will write theorem number 2. If px and qx are polynomials. In this case, limit x tending to a of the rational function px divided by qx will be equal to, that is the property of division. We can write this will be equal to limit x tending to a of px divided by limit of x tending to a of qx. And now we can use theorem number 1. We know that px is a polynomial and hence limit x tending to a of px will be equal to pa divided by limit x tending to a of qx. Qx is also a polynomial and hence this limit will be equal to qa. And because we are dealing with division, we know that division by 0 is not defined, and hence we have to put the condition that qa should not be equal to 0.